Welcome, curious minds, to the very first episode of Relativity Revelations. I'm your host, and today we're diving deep into the genius of Albert Einstein and his groundbreaking special theory of relativity. Picture this, folks. It's 1905, the dawn of a new century, and a young Albert Einstein is toiling away at a mundane job as a patent examiner in Switzerland. Little does he know, he's about to change the way we see the universe. Einstein, a genius disguised as an ordinary clerk, spent his days sifting through patent requests. But his restless mind was on an entirely different track. One fateful day, while he's doodling on his notepad, something incredible happens. He imagines himself riding a beam of light. Imagine, he's surfing the cosmos like a cosmic surfer. And then, bang! The first part of the special theory of relativity drops on him like a celestial revelation. Eureka! He realizes that the speed of light is constant, no matter how fast you're moving. That's the foundation of the special theory of relativity. Now, let's break down this Einsteinian Eureka without losing our cosmic zeal. The speed of light constant. Einstein's first revelation is that the speed of light in a vacuum, approximately 186,282 miles per second, is always the same, regardless of your motion. Whether you're standing still or zooming on a rocket ship, the speed of light remains an unshakable constant. Think of it this way. Imagine you're on a spaceship, hurtling through space at a mind-boggling speed while your friend stays on Earth. When you return, your clocks won't tick at the same rate. Time, it turns out, is not a universal constant. This is called time dilation. The faster you move through space, the slower time passes for you compared to someone at rest. It's like a cosmic version of the slow motion button. Einstein didn't stop there. He formulated a set of mind-bending equations, the Laurence Transformations, which describe how time and space are intertwined. These equations show that as you approach the speed of light, strange things happen to space and time. Space and time become woven together in a cosmic dance. Massive objects, like planets or stars, warp the fabric of space-time, causing gravity to bend the path of light and create the effect we call gravitational lensing. Einstein's genius didn't stop here. He gave us the iconic equation E equals mc squared, which tells us that energy is equivalent to mass times the speed of light squared. This equation underpins the incredible power of nuclear reactions and the creation of the atomic bomb. Finally, Einstein's theories challenged the long-held beliefs of Sir Isaac Newton. Newton's laws of motion had reigned supreme for centuries, but Einstein's relativity shattered some of those convictions. Einstein's Eureka moment in the patent office led to a scientific revolution that changed our understanding of space, time, and the very fabric of the universe. That wraps up episode 1 of Relativity Revelations. Einstein's journey into the cosmos may have started with a daydream, but it revolutionized our understanding of the universe. In our next episode, we'll dive deeper into the mind-bending concept of time dilation and its implications for space travelers. Stay tuned for episode 2, where we'll meet real-life time travelers and explore the bizarre effects of Einstein's theory. Until then, keep questioning the cosmos, and remember, relativity is not just for scientists. It's for all of us to enjoy.